So in this video we discuss about the Meissner effect. So what is Meissner effect? And the Meissner effect, it is indicate the which informations regarding the magnetic materials. So these things are discussed in this video. So what is Meissner effect? So Meissner and Schweinfeld found that if the superconductor is cooled in a magnetic field to below the transition temperature, so then at the transition the magnetic lines of induction are pushed out. So this phenomena is called the Meissner effect, that is the exclusion of the magnetic flux from the interior of a piece of superconducting materials as the material undergoes transition to the superconducting phase is known as the Meissner effect. So the exclusion of the magnetic flux from the interior of a piece of the superconducting material, that is we take the superconducting material. So the superconducting material is placed in the external magnetic field. So what is happened? So the external magnetic field which is act on the superconducting materials, that is the magnetic flux of lines which is acting on the superconducting materials. So the magnetic flux of lines is penetrating, or it is the repelled out from the superconducting material. So in case of normal superconducting materials, that is in a series of experiments on superconducting cylinders, so they demonstrated that as the temperature is lowered to the critical temperature. So in this case we mainly consider as the temperature of the substance. So it's maybe due to greater than the critical temperature of the material or less than the critical temperature of the material. So in case of the temperature is lowered to the critical temperature, so the magnetic flux is suddenly and completely expelled as the specimens becomes the superconducting materials. So that is shown in the second figure. So if we consider the first picture, the temperature of the material is greater than the critical temperature. So the magnetic lines are penetrating through the materials. So that is the magnetic flux which is indicated as the arrow mark, and it is shown in the first picture. So the sphere, that is the materials which is act as a normal material. But in case of the superconducting material is placed in the external magnetic field, that is the temperature is less than the critical temperature. So the magnetic lines are expelled. So it is do not penetrate through the superconducting material. It's maybe due to the nature of the superconducting material. So the magnetic flux are expelled as the specimens becomes the superconducting materials. So the magnetic flux exclusion continues for all the temperature of the substance is less than the critical temperature, that is T is less than Tc. So they established this by carefully measuring the magnetic field in the neighborhood of the specimen. So this is the Meissner effect. So in case of normal material, that is the temperature is greater than the critical temperature, so the magnetic flux is penetrating through the material. But in case of superconducting materials, the magnetic flux, that is the temperature of the substance is less than the critical temperature. The critical temperature is greater than the temperature of the substance, though the magnetic flux are expelled due to the nature of the superconducting material. The effect is which is demonstrated that it is also the reversible, which means when the temperature is raised from below the critical temperature, so the magnetic flux suddenly penetrates the specimen after it is reaches the critical temperature. So on the substance it is in the normal state. What is still In case of Meissner effect, the temperature is less than the critical temperature. Suppose the temperature of the substance it is raised, which is equal to critical temperature, which is, and also we further increase the materials. So the materials which is allow the magnetic flux lines, that is the material, that is the superconducting materials, that is the state of the superconducting state to the material is becomes under the normal state. So the Meissner effect it is reversible. So the bulk semiconductor behaves in an external magnetic field as if inside the specimen B is equal to B naught into H plus M. Here M is the magnetization in the medium, and H is the magnetic flux density, which is equal to mu naught into 1 plus psi into H, which is equal to 0. So therefore psi which is equal to minus 1, that is the magnetic susceptibility negative, which is indicate the superconducting material which is executes the perfect diamagnetism. So in case of perfect, I mean diamagnetic material, the magnetic susceptibility is a negative, so which is also execute the superconducting material. So finally we can say the superconductor which is executes that is which is act as a perfect diamagnetic material. So this is the Meissner effect. Thank you.